So I was running some data to some colleagues, and I finally found the need to adapt the nonlinear regression code to show the regression diagnostics for the Genuchten fitting. So this fitting here is the Genuchten equation with the Mualem's restriction, so we're not going to be fitting for the M parameter, but you can easily add this parameter if you need to. We're importing modules for plotting, for nonlinear regression, for data manipulation, and statistics and general statistics. We're importing the data here using this procedure. So this is the data set. I have water potential psi in kilopascal units, so the absolute value here. We have theta, which is the volumetric water content in cubic meters per cubic meters or cubic centimeters per cubic centimeters, the same thing. So we're importing this data to the program using this module here. Here is the initial value or initial guess to the nonlinear regression procedure. You can easily adapt this to fitting the M parameter as well by adding it here. This captures the initial values of the parameters for the fitting procedure. You need to add M here also for the fitting. This is the function to be fit. It's the Genuchten equation, water retention equation, with the Mualem's restriction. Residual water content, saturated water content, alpha, and N. This here is you need to replace for M if you don't want to use the Mualem's restriction. This here is the procedure for fitting the nonlinear regression using the Levenberg-Marquardt method. You can see details about the statistics in my other video. And this here outputs the values of the parameters and other statistics. So this here is just brings to your terminal the diagnostics. It's just a title. This here calculates the number of degrees of freedom, which is the number of observations minus the number of parameters. This here calculates the standard error of the parameters or of the fitted parameters. This here calculates the t value, the t statistic for each fitting parameter value, the calculated parameter. This here calculates the significance value based on a t distribution. It's pretty simple statistics. All those statistics here I get from these SciPy stats. It's a little function, little macro to print the significance associated with the probability value of the t distribution of the t value. It prints it to your nonlinear regression analysis of variance, if you will, the table that we're going to be printing. So non-significant, significant at 0.05, significant at 0.01, and significant at less than 0.001. This here prints your parameter diagnostics matrix or table. This here calculates a pseudo R squared. R squared doesn't have a lot of meaning in nonlinear regression, but this here calculates the R squared of the predicted versus observed data. This here prints the R squared to your terminal, and this here calculates the sum of squares of the residuals. So some measures of accuracy and precision of the procedure. Whatever is print here, it says print and it's green, it's text that's going to be printed to the terminal, and this here gets the values from the calculations above. This round here is to print a certain number of decimal places. Now for the plots, we simulate a number of psi value or x value, so the maximum minus the minimum value of psi divided by 10,000 to create a lot of data points so you have a smooth predicted curve, and this here plots your data in another window. So plotting here is the observed data, psi versus theta. This here plots the simulated data using the parameters from the fitted function. Y label, volumetric water content, X label, water potential in kilopascal, the absolute value. This asks for the x-axis as log value, and this x asks to show the plot. So it's pretty straightforward. If you need to do the fitting with more parameters, with m, for example, it also need to add another parameter in each of these procedures. So you have SC3 here, you need to add SC4, PCOV 44, T4, just follow the what is being done in the previous ones and do the same and add the parameter here and it will be work fine. And you also add here another line, just mimicking this line here, just changing the values and it would fit with the M. The fitting is actually more easily done by the nonlinear procedure with less parameters. Now we run the procedure. We have a window here with the output and the plot. So this here is the covariance matrix of the parameters. These are your fitting parameters. This is the analysis of variance, if you will, of the fitting parameters. This is the value of the parameter, calculated value. So theta S is 0.50, theta R 0.23, saturated water content, residual water content, alpha parameter, and N. 0.50, 0.23 for theta R, 0.1011 for alpha, and 1.8607 for N. This is the standard error associated with parameter. You can do a lot of statistics with standard error. This is the t value, the calculated t value. This is the probability associated with t, and this is the significance. So all values of the calculated parameters were significant at t at a probability of less than 0.001. This is the pseudo r squared of the predicted versus estimated, and this is the sum of squared of the residuals. So it's pretty straightforward. If you need, you can adapt it however you wish. And this is the plot. This is orange here, golden is the predicted line, and this here, the stars, blue stars here, are the observations.